I'd like to thank everyone who's joining us today. Welcome to today's CNCF webinar, Monitoring Kubernetes Workloads, the Sidecar Pattern. I'm Chris Short, CNCF Ambassador. I also write DevOps-ish, and I work at Red Hat. I'll be moderating today's webinar, and I'd like to welcome our very special presenter today, Caleb Haley, CEO at Sensu.
Thanks, Chris.
A few housekeeping items before we get started, Caleb. During the webinar, attendees are not able to talk. There is a Q&A box on your screen. Please feel free to drop your questions in there, and we'll get as many answered here as we can. Also, there'll be time for Q&A during the discussion and at the end. So if we don't get your questions answered, we will attempt to get them answered after the fact as well. Without further ado, take it away, Caleb.
Awesome. Thanks for the introduction. And I'm Caleb, CEO and co-founder at Sensu. That also makes me kind of one of the biggest cheerleaders for Sensu. Happy to be on the CNCF webinar today. And we're going to get caught up with our overview for the presentation today is to get caught up a little bit since a guest blog post we had on the CNCF blog a few months back. That was the beginning of our Monitoring Kubernetes blog series. And so we'll kind of recap some of the main points that we covered there and then continue that conversation with a discussion today about going beyond monitoring Kubernetes to monitoring workloads on Kubernetes. And we'll do that with the sidecar pattern, and I will tempt the demo gods with a live demo. Containers, cloud native computing, these are our new reality. Businesses certainly are adopting the cloud native movement, and we think that that means things like strategies like multi-cloud are here to stay. They're necessary for the modern business to stay competitive. And our industry, I think, has for a long time been relying on microservice-based architectures in order to compete. Everything is about moving faster, right? So microservice-based architectures have been a big movement there, and this advent and near ubiquity of microservices kind of naturally paved the way for container technology. This has been my personal perspective on the fast growth around containers, and that has really allowed us or enabled us or even forced us to rethink how we build and deploy our applications. So then you had Docker came on the scene, and Kubernetes, and the rest is history, as they say. So we started that blog series. Part one was featured on the CNCF blog a few months back, and in that first blog post, really talked about what are some of the challenges around monitoring Kubernetes, and some of those challenges come from the vast variety of data sources you have to take into consideration when monitoring Kubernetes. You have data coming from the Kubernetes cluster itself and projects like the kube state metrics, each individual kubelet, the engine behind Kubernetes that runs on each of the nodes in your Kubernetes cluster, the underlying compute resources, of course. These are all abstractions, so we do need, in order to get some proper visibility into the health and performance of our system, we need access to monitoring data all the way down the stack. So those were some of the things we focused on in the first part of the blog series. And then as that blog series continued on, we got into some of the strategies. And in this parts 2, 3, and 4 of the blog series, we really talked about Prometheus as one of the more popular solutions for monitoring Kubernetes. It makes a great companion as a telemetry-based solution. What we didn't get to, kind of segueing beyond that blog series, is some of the other monitoring strategies that exist. So we did talk about Sensu and how it complements a Prometheus or telemetry-based approach to monitoring, and specifically to monitoring Kubernetes. And but we didn't really talk about what those strategies are. So we think kind of an observability strategy for Kubernetes involves some amount of remote polling. This would be a traditional service health checking capability, some amount of node-based monitoring. So you have some monitoring agent that lives on the Kubernetes underlying Kubernetes host, or can even be operated as a daemon set inside the Kubernetes cluster with the appropriate configuration to be able to gain access to information about system resources and whatnot of the host. And then there's also a sidecar model or strategy for monitoring both the Kubernetes system itself as well as the workloads that are running on Kubernetes. That's the one we're going to focus on today. And then, of course, there are logs and APM. So that's a little bit out of the scope of our discussion today, but perhaps for a future webinar and or continuation of our blog series. So we'll focus on, for the rest of the presentation, this pattern that is sidecars. And we'll first answer the question, what are sidecars? And in preparing these slides, I kind of paused for a moment and acknowledged or realized that sidecars in and of themselves as a pattern are not actually a formal convention of Kubernetes. And so a little bit of research via the Googles, I found the only canonical reference to a sidecar is here with air quotes. Thankfully, I have my video on, so we can show the air quotes. But this concept of pods that are running together, or a number of containers that you would compose together in a pod, where one or more of those containers are providing some kind of infrastructure service. This is where this concept of the sidecar comes from. Do you have a comment, Chris?
Nah, it's funny to me. Like, there might even be people on this call right now that don't even understand like what a sidecar, like what it's named after, right? Like,
right.
Motorcycles used to have cars attached to them, like little carts that people sat in, and they did nothing, and the other person drove a motorcycle. Well, now sidecars are actually doing a ton of things, and yeah, let's keep going. I like it.
Yep. I think one of the earliest references to the sidecar pattern, this may even have been on the CNCF blog. It was a few weeks ago when I put these slides together, and I didn't leave myself a speaker note because I thought for sure I'd remember this, but it was like 2015, I want to say. And in this blog post, it mentioned 2 or 3 other patterns that were popular at the time that were not baked into the Kubernetes platform. And I think one of them is now kind of like a proper supported workflow or pattern in Kubernetes. The other 2 have long since been left, in the past. Where the community around Kubernetes is moving fast, obviously, experimenting with various different workflows. It's still early days, I think. And so not everything sticks, but sidecars, it seems, are here to stay.
Yep.
Which is kind of an interesting basis for our discussion today. So what are some of the benefits? I'll be curious to get your thoughts on this on the next slide, Chris. But from our perspective, we think, could you bake some of the functionality or content or services of a service that you might run in a sidecar into a single container? Are we then trying to build these little mini monoliths inside of our microservice architecture? Certainly you could, but breaking those things apart, you get this nice modular, composable, and all the nice attributes that you think about when you think about microservice architectures apply, I think, one-to-one to this sidecar pattern in Kubernetes.
I would agree.
Yep.
Yeah.
Cool.
The one-to-one, absolutely.
Yep. Cool. So then what are some examples of things that happen in sidecars? And this is certainly not the exhaustive or canonical reference for things that you can do with sidecars. But some of the more popular or obvious ones that we've seen are, if you've heard about the service mesh, very often the service mesh is implemented as a sidecar. And there are various logging solutions or logging platforms that have agents that want to be run as sidecars. And Sensu is by far not the only monitoring solution that provides an agent which can be run as a sidecar. So you have this nice one-to-one pairing of monitoring agent per collection of services that works pretty well. So before I continue, I promised I would pause momentarily as we went through the presentation and look at the Q&A. So let me see if we have any questions yet. None yet. That's good.
Yep.
So I will now tempt the demo gods with a live demo. And
would you like me to sacrifice a pen or something before you begin?
Yeah. No, I think we're going to be okay.
Okay, cool.
So let's do the old, tell them what you're going to show them, show it, and then talk about it thing. So for the first part of our demo, I'm just going to deploy an example application into Kubernetes using Kubernetes deployment. So we'll look at the deployment YAML. The example application is just going to be an nginx, default nginx website. We'll look at the deployment YAML, we'll deploy it, we'll then go see our live running app. And this can kind of bring us to the place that maybe a lot of the people who are attending today and people who may be interested in this particular topic may have reached, which is, cool, I've deployed my app or service into Kubernetes, now I have to figure out how to monitor this thing. And maybe you had a different workflow or different tools for doing that outside of this kind of cloud native context that don't necessarily work very well in that highly ephemeral compute environment that you attain by using Kubernetes. And then the second demo that we will do, we'll look at how do we now take this thing which I have deployed and start to monitor it. Okay, so that's what we're going to do. And let me pull up my screens here. And there's quite a few moving parts. I apologize for that. Okay, so the first thing we're going to look at is an extremely simple example of a service. And let me know if this text is too small, yeah, Chris. I think we looked.
Preset, please. Thank you.
We looked at my terminal earlier, but not at the text editor. How's that?
One more, probably good.
Okay.
Looks good to me.
Okay.
If anyone else has a problem, let me know.
Cool. So this is intentionally extremely simple here. We have a service. The nginx container by default wants to run on port 80. I'm going to expose that outside of the Kubernetes cluster at port 8000. And then I have an extremely simple deployment. And this deployment is just running the upstream nginx container, just the latest iteration of it, and configuring that port. So let's go ahead and deploy this. And you can see on the bottom here, bottom pane of my terminal, I'm just running the Linux watch command so we can see live the current state of the pods running in this Kubernetes cluster. And on the top, I will be issuing my commands. You can also see it's outside of the scope of our demo today, but we will provide as one of the follow-up action items, the materials I'll share at the end, instructions for how to deploy Sensu into Kubernetes. But I have my Sensu here running in Kubernetes, and I actually have as a companion to Sensu InfluxDB as a time series database and Grafana for building custom graphing dashboards. So I have like a reference architecture telemetry pipeline. Sensu as the collection, and then the other components there. Okay, so let us to help myself avoid any embarrassment. I created these little scripts, but I'll do it the verbose way. So I have created a namespace in Kubernetes called webinar. That's where I will. That is where I will create all my resources, and I'm going to provision these pods. So that is nginx deployment. I already pre-provisioned my service. My Kubernetes cluster is running in Google Kubernetes Engine. I didn't want to have to wait to get an IP address. So that is already there. But I've now actually deployed 3 instances of this nginx service. I will now let's see, namespace webinar, get services, and I'll copy that. Oops. And we will go to our browser and observe at port 8000. Voila, I've just launched my fancy new service. I'm live on the internet, all powered by Kubernetes. Very cool. So again, the purpose of this step in our demo is just to kind of find common ground with users. So if you have reached this stage in your kind of application operations lifecycle onboarding onto Kubernetes and are now interested in methods to monitor that service, this is where we will try to make it interesting. So I have a secondary Kubernetes deployment YAML. This is identical to the first one we've shown, but this is to show what is involved in adding the Sensu sidecar to your application deployments. And this works with Kubernetes deployments. It works with all the controllers. So it works with deployments, stateful sets, daemon sets, and so on. So to add Sensu agent sidecar, I just add another container in the spec.template.spec.containers scope of our deployment YAML. And I'm going to use the latest version of Sensu. And as you can see, 100% of Sensu's configuration is exposed in a very cloud-native friendly manner. So the Sensu agent, you can configure it via like command line flags. So I can provide some of the configuration that way. I can provide all of it that way if I wanted. But also we expose 100% of the Sensu agent configuration as environment variables. So you have this very Kubernetes native declarative configuration workflow available to you to configure how you are running the Sensu agent how you're configuring the Sensu agent. So this is the configuration I need for my adding my sidecar, and now let's deploy it. So you'll notice too that I have this rolling update strategy here. Let me actually slow this down so we could talk about it while it happens. So as I try typing and talking at the same time. Kubernetes, nginx, deployment with, okay. So when I ask Kubernetes as my cloud provider, control plane here, to update the configuration of this deployment, we will see it also apply this rolling update strategy. So I have this highly available example application running here in Kubernetes, and I will update one instance at a time of the applications that are running in this Kubernetes cluster. And as those new pods come up, and they have the Sensu agent sidecar, and then we'll get to see one of the cool features of Sensu, which is this automated registration and deregistration of nodes, and that could be bare metal compute instance, traditional virtual machine, or cloud native compute, so a container or pod. We'll see those automatically register here in my Sensu dashboard. So go ahead and trigger that. Down on the bottom, we see my first pod has provisioned. It'll wait 10 seconds before it takes down another instance, and then it will then provision another one. These are automatically registering into the Sensu dashboard. So wait for that to complete. So getting started with Sensu in Kubernetes is quite simple. As I mentioned, again, I'll share all this configuration at the end of our presentation. Okay, now the other cool thing about this is now that I have this configuration in place, I can also scale this thing. So let me scale my deployment, and I'm going to say, let's say 10 replicas. As I do that, I can see live, again, Kubernetes is provisioning new compute instances. This is all pretty easy. I think from a monitoring perspective, a lot of tools will do this very well. The thing that Sensu does exceptionally well is not only the automated registration, but also the automated deregistration of systems out of monitoring. So again, this works cross-platform. So for your traditional bare metal compute, traditional on-premise virtualization, multiple public cloud providers, and even in cloud-native environments, we can tell the difference between a node being down and one that's been deprovisioned. So that's a whole probably topic for a separate conversation. Okay, I see there's a question that looks like a great question to answer now instead of waiting for the end. So the question is, what can a monitoring agent do in a sidecar that it cannot do in its own pod? So this is a great question, and probably one that you can help me with, Chris. And the answer to the question is that you get this one-to-one mapping. So part one of the answer is, for every instance of a pod, which can be a collection of services, and in some ways you can almost mind map, a pod to what you might have provisioned a VM for previously, right? So if you had a microservice architecture that said we have compute instances that have a role. That role says it's going to run, X, Y, and Z service. You would, of course, have had things like monitoring agents and whatever else on those compute instances as a one-to-one mapping. So even in a clustered service, you would have, this complete set of services to make up, an individual instance of a service. And that concept you can kind of carry over into Kubernetes using the pod concept. And the reason why it's beneficial and why it works is that all the containers in a pod, this is the part that you can help me with, Chris, all the containers in a pod have a shared network address space. So they can talk to each other via localhost, right?
Right. So to kind of dive into the mechanics of that, the pod itself is a form of isolation. So to have another pod reach into another pod, there's a lot of kind of gooey, icky configuration that has to happen to make that viable. And it's not really like a great, thing to do kind of long-term strategy-wise. So putting these sidecars in, or putting a collection of pods or putting a collection of containers in a single pod allows you to say, oh, I have this tiny little cache, like, whatever, Redis cache running with this, Go application, and I need to make sure that everything's running within a certain, request per second ratio. The best way to get that is from that pod itself, not to add some latency to that, to then, automatically scale up and down the size of your pods. So this provides a real-time or near real-time, and then B, very, very, very close and granular access to what is running in a pod.
Yep. Well said.
And I just went back and checked the Children's Illustrated Guide to Kubernetes. Did not mention sidecar, but it did mention pods can contain multiple containers. So, don't know. That's another interesting reference point for you for your history there.
Right. Just the not very solid footing on which sidecars as a convention in Kubernetes are standing, although the popularity is unquestionable, I think, right? Like the pattern is here to stay.
We got a couple more questions, but if you want to keep pushing.
I see one of the questions was volunteer answer from the attendees to the question we just answered. I think we covered that. There's another one that says, is there any way we can separate Sensu configuration from the original app pod so the developers do not need to think about the monitoring configuration? There's a couple different ways to approach this. If I go back to look at that deployment YAML, I think what the question is saying is, if I'm a developer and I'm responsible for deploying my service on Kubernetes, I'm going to be responsible for this part of my provisioning template, right? This is all the configuration that's needed actually to run my app or my particular service, and a contract between the application engineering teams or service engineering teams and the operations engineering teams or your site reliability engineers sometimes is that the contract is we will take care for the monitoring. You just give us the thing to deploy. And there are a couple different answers there. One of them is on our roadmap. Doesn't exist yet today, but that is the concept of I think it's called an admission controller in Kubernetes. So what this would do is you would have a service that lives inside of your Kubernetes cluster that says that it's kind of like the gatekeeper for things that are provisioned into your into Kubernetes, and it can apply rules to the services that are provisioned. And one of those rules is, hey, we want a Sensu agent to be a Sensu agent sidecar to be present in every single pod within these namespaces, or something along those lines. And then you can apply the configuration of the Sensu agent in that way. Some other things that we can do are you can move the what's available today is all this configuration can also live in a config file. So you can make that configuration file available as a config map inside of the Kubernetes cluster, and then you can volume mount that config map into the Sensu agent. So that would eliminate a lot of this configuration. You'd have about 4 or 5 lines of boilerplate boilerplate here, just saying I'm adding the Sensu agent and I'm volume mounting this config file. I don't know what's in that config file because that's maintained by someone else, but that's what I've been told to do to add monitoring to my apps. So, and there's quite a few other strategies we could discuss, but probably out of the scope of the conversation today. So hopefully that's a helpful answer to that question. Okay, let's resume the demo. I see the questions are continuing to pour in. Hopefully that means we've found ourselves a nice, relevant conversation, because I haven't actually monitored the thing yet, right? All I did was just say how to get started.
You put it there.
Yeah, I turned it on. But I'm not actually. Yep. Okay, my work is done. I'm going home. So now let's talk about actually monitoring that thing. So let's go to another demo. And in this demo, I'm going to talk about a few things. One is, and I'm now realizing in real time, I probably could have provided a little bit of an architectural diagram here, but one is I'm going to talk about the architecture of Sensu and how the services communicate. So our Sensu agent communicates with the Sensu backend in a pub-sub model of communication. The agent actually only requires outbound network access, so we don't have to open ports in the agent or on the pod or on a virtual machine or whatever in order for the monitoring backend, like the monitoring control plane, to have access to the individual agents. So the agents just have an outbound connection. It's actually TLS encrypted WebSockets in Sensu Go, and they maintain this connection with the Sensu backend. There's built-in support for high availability, so if it loses connectivity with one backend, it'll just fail over to another one. And when that agent connects, the agent says, "Hey, it kind of describes itself, the roles of that particular agent. And in the case of a sidecar, it might say, "Hey, I'm on Kubernetes. I'm a Docker container, and the role of this thing is, in our case, a nginx service, or a web service, or hopefully you're not running stateful workloads on Kubernetes. This is also a topic for another day, but on a virtual machine, you might say, "Hey, I'm a MySQL server or Postgres database," or whatever the case might be. So the agents will subscribe to topics for each of those. We call them subscriptions. So the agent will subscribe to a number of subscriptions on the back end, and then that back end, as your control plane, is where we will configure the monitoring to say, "Hey, I want to collect this monitoring data from from all the members of my nginx subscription." That's the demo we're going to show today. And what else do I have? We're going to configure a very simple check. And in fact, I'm going to use, which is hopefully a little bit surprising, Sensu provide support for a wide variety of plugins, from all the way from old Nagio style collection plugins to we have in our agent a statsd socket. So if your apps are configured, let's say for custom metrics on Datadog, and you need to use something other than Datadog or something behind the firewall, you just point those things at your localhost statsd socket. The agent collects those metrics. We also have support for collecting metrics from Prometheus endpoints. But for the demo today, I'm actually going to use an old Nagios plugin, and the old CheckHTTP plugin. We think a lot of operators and engineers have some background with Nagios for better or for worse, and have some familiarity with that plugin. So we're going to show how that can be used even in this modern context, both to check the health of our service and to collect metrics to make a nice, pretty telemetry dashboard here. Okay, so we already have those subscriptions in place. So now I just need to provide the Sensu configuration. So let's look at what that looks like. So in Sensu Go, if there's any attendees who are familiar with the older version of Sensu, this is going to be new. In Sensu Go, we have a couple new features to talk about, one of which is also the Sensu configuration file format, which should look very familiar to Kubernetes users. Our configuration can be provided as YAML or JSON files. There are 4 top-level attributes for every single Sensu resource: a type, an API version, metadata, and spec. I think if you change this from type to kind, it would look like Kubernetes YAML. So here in this configuration file, I am registering a handful of monitoring plugins. These are called assets in Sensu. So these are any HTTP fetchable, tarball, optionally gzipped. You have to require a SHA-512 so we can verify the integrity of the asset that we're fetching. We register these in the control plane in the Sensu backend, and then we associate them with our monitoring check configuration. So this is monitoring check in Sensu, and you can see I'm giving it a name. I'm saying this is the command that's going to be executed. So the Sensu agent is actually just going to execute a service check. I'm publishing this request on a 10-second interval to the nginx subscription. So whether if it's a container or a virtual machine or a bare metal host, any agent that's a member of that subscription will receive this request every 10 seconds and execute the check. And then I'm referencing those plugins that will be needed for the agent to execute this check. I don't have these installed in my Sensu agent, so they will need to download these assets, one or more of these assets, in order to complete this check. And then I'm informing Sensu that, hey, the output of this check contains some telemetry data in Nagios perf data format, and I would like to convert it and write it into InfluxDB. So that is an overview of the Sensu check configuration. And now let's go look in our Sensu dashboard. We'll see I don't have any Sensu checks configured. And so I will now say Sensu cuddle, which this allows me to also to introduce our command line utility, which again should look and feel very familiar for Kubernetes users. In Sensu, we also have the similar concepts of namespaces and RBAC. That RBAC includes roles and cluster roles, and role bindings and cluster role bindings. So again, some familiarity there. And I'm going to use this same even create-f workflow here and go ahead and create that nginx monitoring check. And so in real time, I see that configuration appear in the Sensu dashboard. I could come, if I'm a different kind of user that doesn't like the command line, I could actually come here and edit this check configuration or create new ones, modify it in some way. But if I go to my Sensu dashboard and I say, show me, all the results of this check, it's already been executed on all 3 of those pods. And I see this old school Nagios output here. Chris, looks like, I see a little smirk on your face, like maybe you've seen this movie before.
Yeah. Like maybe nightmares, maybe repressed memories, maybe happy.
Yeah. There's good and bad. I think a tool like Nagios couldn't be around for 20 years if it didn't do something right.
Exactly.
And the thing that we think that Nagios got very right was this concept of the service check, right? It's very easy to reason about how to write a little monitoring script. And now, we wrap some niceties around it, like a simple packaging and distribution mechanism that we provide in Sensu, and you can do cool things with it. Okay, so I want to eventually have a dashboard to show for all this. And in Sensu, we do that with what we call handlers. So Sensu, we think about as like a monitoring event pipeline. And so that the event reference there is kind of a nod to Sensu's architecture. But that event data can be service health checks, like its availability information, right? Like, is this thing up or down? Is it healthy? It can also be telemetry data and the discovery data we already saw, right? So Sensu kind of keeps track of, hey, here's a new node, or that node has gone away, and then we can use handlers to process that data. We have a InfluxDB handler we're going to configure here to pipe the telemetry data that we're collecting, even though it's in Nagios format, convert it to InfluxDB format and write it into InfluxDB. So I'll do that here like this. Webinar, create Sensu handlers influx. And now that I have registered the configured Sensu, registered those resources and configured Sensu to start sending out telemetry data, I will start to see metric data points in my dashboard. So if we give this a second, my dashboard is refreshing on a 5-second interval. Our metrics are being collected on a 10-second interval. I have now a complete end-to-end telemetry pipeline in this very modern context that is Kubernetes, using, it didn't require, heart transplant surgery. So if I'm coming from a place where I was using, Nagios still, or any of the Nagios derivatives that have popped up over the years, which is a surprising number of organizations, and now I'm moving those workloads into cloud native compute environments, and need a solution for, wait a second, Nagios isn't going to work in this environment. Do I have to throw the baby out with the bathwater? The answer is no. So this is cool. And then kind of the finishing touch we will do here is, remember previously when we scaled our deployment? So now when I do that again, I get those 7 additional instances of this app, making my service more highly available. And that means I have sidecars in all of those places. And as those Sensu agent sidecars come online, they don't have the plugin I need to perform this monitoring check yet, but Sensu takes care for all that. So the agents receive this request to perform this service health check. They execute the request. They send the results back to the Sensu backend, this pipeline, and we go and take that data and do as you wish with it. Some of the other handler things you can do with Sensu is obviously send alerts. So we have like PagerDuty handlers that would just notify you if a thing is down. If you want to write data into Elasticsearch or Splunk instead of time series database like InfluxDB, we have solutions for that. The possibilities are really very endless, and but that's also a topic for a different day. So let me look at the questions.
I've answered a few. There is one open one talking about the Nagios performance data going to the graph. You're using Grafana, it looks like there. Could you talk about more maybe about how that connection between the Nagios HTTP check becomes that chart?
Yes, absolutely. So you can do some Googling on the internet to find a reference to the Nagios perf data or performance data specification. And this was in a different era when this was created, and was both human readable output as well as what was supposed to be machine readable telemetry data, right? And so this old Nagios check is actually emitting 2 metrics. This would look very different in the Prometheus exposition format output that we may be familiar with if we're using Prometheus, or the influx line protocol, or graphite plain text protocol. Like, there are a number of these like time series data exposition formats or wire formats. Nagios is from a kind of even earlier generation than that, but these are telemetry data points that are being collected by Sensu, and we have in the Sensu agent a parser that will parse these metrics at the edge. So the agent actually, in receiving the output of executing the script, has been informed that, hey, this output string I'm seeing here contains some telemetry data that I know how to parse. So it's extracting those two metrics into a Sensu internal format, and then we send that's into like a JSON data payload. That's how the data flows through the Sensu pipeline. And then on the back end, we have a handler. So if we go back and look at our check configuration, so we told Sensu, hey, I want to use the InfluxDB handler, and then we configured InfluxDB handler here. This is the name of it, which is, this version of it is just actually piping out to execute a plugin that is writing data to my InfluxDB backend with super secure credentials. So please, no one hack my demo environment. And I can also further apply. Sensu provides like a transformation step in the pipeline. So if I want to apply a mutator to further mutate the payload that's flowing through the pipeline before it reaches my handler that's going to process that data by writing it to the data store, then I could do that, which I have configured here. These resources are available in a new service that's in beta currently that we call Bonsai. So this is kind of like the Docker hub for Sensu. And if I come here and search for InfluxDB, I'll see that InfluxDB handler, which gives me some more documentation that explains exactly how the thing works and what configuration is available for it. But then if I come and use the query editor here in Prometheus, and I'm looking at which metrics are available in Prometheus, in Grafana, and this Grafana is connected to my InfluxDB backend. When I go use the query browser to browse what metrics are available for my little webinar demo environment, I've only collected metrics from this one check plugin, and the two metrics I see here are the same two that I see in the Nagios perf data output. Does that all make sense to you, Chris?
Makes sense to me.
Cool. Hopefully that's a helpful. Correct. Yep.
So basically, the recap is there's some Sensu captures the data from Nagios checks, parses it, and then pumps it into InfluxDB, which generates this dashboard.
Correct. Okay, let's go back to our slides and see if I can make for an on-time conclusion here. I have published part of the configuration for this presentation already in my personal GitHub that is here, github.com/CalebHaley/monitoring Kubernetes workloads. And I will upload the remainder of the configuration to reproduce this in your own Kubernetes cluster later on this afternoon. That way it'll be available by the time the video is up on YouTube or wherever it ends up. So if there are other questions, I can answer them now. Let's see. In your example, what kind of health checks are you doing? I wanted to understand what these can complement on top of the Kube state metrics. So great question. The Kube state metrics project, and let me see if going to the Googles in a webinar could be dangerous, but let's try it. Kube state metrics. Yep. So the Kube state metrics project is a Prometheus exporter. Oh yeah, good call.
Thank you.
Let's do that. Thank you. Let's keep going. Whoa.
There you go.
Little delay there.
Okay.
Extra large. So this is an add-on for Kubernetes that exposes metrics about the Kubernetes cluster. So each of the kubelet backends has a /metrics API. I forget what the port that it runs on is, but that exposes metrics about the individual Kubernetes node, and that's compute resources, the number of jobs it's running, and this sort of thing. All telemetry data. Kube state metrics is going to expose expose other data about Kubernetes resources across the expanse of the cluster. So this is at the control plane level, and it's giving me performance data about, the total number of jobs, all the kinds of metrics about the duration of those jobs on Kubernetes and whatnot. But it's not actually giving me very granular telemetry data or metrics about the workloads that I'm running on top of Kubernetes. Let's see. Does maybe this even? What metrics does this give us?
I think if I can interject a little, I think the biggest
please.
kind of thing to take away from all this is that sidecars are kind of this new concept, kind of an add-on after the fact concept potentially. Cube state metrics is also an add-on. So, we know that there's an enormous amount of data generated by Kubernetes applications and Kubernetes itself, but how people actually manage it and use it is kind of not unknown, but still getting felt out to an extent. So
correct.
Yeah, the cube state.
It's early days.
Right, like the cube state metrics are going to tell you exactly that. Kubernetes state metrics, right? Like if I'm, if I'm that DevOps engineer of old that I used to be, and I need to know that, hey, I've got a bad pod somewhere, which one's performing poorly, that's not going to come from that, right? Like it's going to come from something like Sensu, or I'm going to have some other thing in place to say, oh, this is a noisy log kind of deal, or oh, a low number of connections over here.
Correct.
And this, like there's a higher level of granularity that you get from something like Sensu.
Yep. And what's nice about, and I'm not going to try to repeat everything we said in our blog series. We're big fans of Prometheus actually at Sensu. Maybe not something you would expect from what appears to be competing open source projects, but Prometheus is a wonderful telemetry focused monitoring solution. And the model is actually quite interesting. And there are some nice things about it that make a lot of sense in a cloud native computing environment like Kubernetes, where you have this orchestration abstraction between the app, the way you're developing it and running the thing. And a great answer in some cases to the question that we answered earlier, that was about, hey, I don't want the developers to have to think about modifying their deployment YAML to know, like they don't need to know where monitoring is, right? Prometheus is great for that because you can instrument your applications, you expose metrics, and you're done. Like you can say, hey, I did my job, the metrics for my app are available, something else is going to come along and scrape them. That's great for, again, but that's telemetry focused. So if you need also that kind of functional service health checking, you sometimes trying to, that's like that, I have this hammer, I'm going to smash all the problems with it. Sometimes it doesn't make sense to map, is this thing healthy or not, up or down, to a 1 and a 0. And in that case, you need a more functional. Yeah. Yeah. If you need a functional service health checking, now you have to look elsewhere. The other trade-off between Prometheus and Sensu's approach, I think, is Sensu gives you a single sidecar solution. Whereas if you had services running as containers in a pod, and each one of them you had a Prometheus exporter for, those are like single purpose agents, right? So you have one Prometheus exporter per service, and each one of them requires port configuration so that you can go and collect the metrics from them and whatnot. And depending on, we have a lot of conversations with customers who are saying, we love Prometheus, but opening ports in our network is a non-starter for various compliance or security reasons and whatnot. And they would have to audit the security of each individual exporter, as opposed to, there's a smaller surface area when you have a single, multi-purpose agent like you get from Sensu. And sometimes in our blog series, we talked about there's like a very good companion solution there, which is use the Prometheus exporters and use this local Sensu agent to locally scrape those metrics, shove them onto the pipeline. Now we can go write them wherever you want. And we have a great story for that in Sensu, and a bunch of customers who are doing that at pretty significant scale into the tens of thousands of nodes with an unknown number of containers even running on top of those. Okay, I think I got a tiny bit off track in answering that question, but yeah.
So, okay, quick one. Is Sensu available as on-prem solution or only SaaS? I think you answered that. It's both, correct?
Actually, there is not a SaaS available.
Oh, okay.
Historically,
Got it.
Sensu has only been on-premise. This is a funny question for us because 95+% of our customers are running Sensu in the public cloud somewhere. So on-premise in Sensu's use case, because it was, Sensu was designed as Sensu was cloud native before there was the term cloud native, right? Sensu has only known a world in which public cloud existed, and that was kind of the problem it set out to solve.
The hundreds of data centers across the globe, kind of
correct.
Known AWS and Google, yeah.
But the nice thing is, solving that original problem we set out to solve, which was monitoring is kind of like, hey, is this thing working, right? It's like Big Brother tapping on your shoulder, and when you have this ephemeral compute and that thing can suddenly go away, the old school style of monitoring that's like, crap, this thing went away, I need to go wake somebody up, doesn't really make sense. So you need monitoring that understands this like ephemeral compute environment and this infrastructure as code development workflows and how to go, Sensu can do things like, hey, I think this node might be down, I should probably wake somebody up, let me go ask an external source of truth first and go talk to the Kubernetes API or the EC2 API and say, hey, external source of truth, what do you think? Do you think this thing should still be running? And EC2 says back, oh no, I terminated that instance, right? I don't think it should be running. So we can safely remove that system from monitoring and not go wake somebody up. We can do the same thing with the Kubernetes Pods API and every other cloud provider quite simply with Sensu. So,
Nice.
So yeah, on-prem for us means cloud. It typically means multi-cloud or hybrid cloud. But yeah, Sensu is on-prem. Yes, behind your firewall, we'll say. Let's go ahead and make sure we get get through our closing slides here. And I should probably pull the slides back up before I click through them. Upcoming events, our third annual Sensu community event, the Sensu Summit, is coming up this September 9th and 10th in Portland, in the building I'm in today, right now, Revolution Hall. It's an old converted high school. So we'll have some fun going back to high school themed stuff happening at the event. But a great time to get together, meet the Sensu team, meet a lot of the Sensu community, and we have a little discount code here for our attendees of the webinar today, and we'd love to see you there. We promised we would offer a solution to answer questions after the fact. You can do that by joining our community channels. That's our Sensu community Slack, or our discourse channel is probably the best place. You can go there, post a question. We're usually pretty timely about responding to those questions. If there are unanswered questions at the end of this webinar, please feel free to go post them there. Or we might beat you to it. So we will usually take the unanswered questions from our webinars and post the question along with an answer to create some opportunity for follow-up discussion. I showed briefly our new hub for sharing Sensu plugins. There's a lot of content to be published there leading up to our event. We'll have some announcements around that at our upcoming event. And of course, there's KubeCon coming up. So not only will Sensu, the company, be there, I myself also will be present at KubeCon. So if you have follow-up questions that you want to ask me in person, I would love to hang out with you in sunny San Diego. I think there's a bunch of words I'm supposed to say about this, but the most important one is just go to KubeCon.io. That's where you can register. Anything else I'm missing there, Chris?
KubeCon.io, got a discount
dates,
code in there earlier.
San Diego. Yep.
Yeah, I think you're good. Yeah, get your education on. Show up for the Contributor Summit earlier if you want. That's my ContribX plug. How about that?
Awesome.
Cool. Thanks for everybody for joining us today. Really appreciate your time today, Caleb. Thank you for educating everyone on Sensu, sidecars, and many, many things, metrics and telemetry. The webinar recording and slides will be online later today. Take some time to convert the Zoom format to YouTube formats, all the other formats. We look forward to seeing everyone in the future, and thank you again, Caleb, for joining us today.
Yeah, thank you, Chris. Thanks for your help answering some of those questions. It was fun.
No problem. Thank you. Have a great one.